In today's lesson, we are looking at piecewise functions. We're going to look at evaluating them, graphing them, and writing them. So in this first example, this is the function f of x. So this function is where it takes a piece of one function. So we're looking at this function, but only for this domain. And we're going to look at this function for this domain. So to start out, we're going to just evaluate this piecewise function. So I'm going to do a few different examples. Let's first look at f of 1. So we know that that's just function notation, plug in 1. But where do we plug in 1? We have to look at where 1 is defined in the domain. So 1 is only included in this top function, so we don't even consider this bottom part of it, the bottom piece. So we are just going to plug in 1 to the top piece, 1 minus 1, which is 0. Next example, f of negative 4. For this one, let's see, negative 4, where is that in the domain? That is not in the domain at all. The smallest x value that we care about is negative 3. Well, really, just above negative 3. So this is not even defined on this piecewise function. Okay, let's look at f of 0. Where is 0 defined in the domain? Again, we're still looking at just that top piece. So the square root of 1 minus 0 equals 1. Okay, let's look at f of 2. We are now switching to, 2 is within this domain from 1 to 5, so that means we're just caring about this function. 2 minus 4 is negative 2. Okay, f of 5. So here's 5, and it's including, so we will plug 5 in. 5 minus 4 is 1. Last one, f of 10. 10 is not in the domain, so this one is not defined on this function. So evaluating piecewise functions is pretty easy. You just have to know which piece you're dealing with depending on where your value, x value, falls in the domain. Okay, now we're going to graph a piecewise function. So the two pieces are both linear. So we care about this top linear function, but only on this domain, and the bottom linear function on this domain. What I like to do is first look at all of the values, kind of the ending points of the domain, and just kind of put marks on my graph. Just kind of helps me visualize where everything's going to be. Now, what I'm going to do is first just think about this top piece, this 1/2 x plus 1. It has a y-intercept of 1, slope 1/2. So don't start graphing this yet. I'm just going to show you. Let's see, I'm going to put my y-intercept on there, and I'm going to put all these up 1 over 2 points. Piecewise functions, it's definitely good to use a pencil with, because you like to graph it, and then I will erase the parts that are in the domain. So in this case, we only want this function that I started to draw from negative 4, from where x is negative 4 to where x is 2. But now I have to fix something because I'm going to have a closed circle here, but there'll be an open circle there. So open circle, closed circle, and I will connect these. But now all those other dots that I drew, they are not within the domain that I want, so I am getting rid of all those dots. Okay, so now let's graph the other one. There's 2 minus 2x. Same thing, I'm going to get dots on there, and then I'm going to end up erasing some of them. So I start at positive 2, and then my slope is down 2 over 1. But I only want for x values greater than 2. So at 2, here's my open circle, and then greater than would include all of these onto infinity. But then I need to erase all these other ones that I drew. So there is the full graph of f of x. This piecewise function are both of those combined. And this is an example of jump discontinuities. So discontinuities are those vertical asymptotes and the holes that we've been working with. And then this is the other type of discontinuity when we have a jump in a piecewise function. Okay, now the last part of the video is, here's the graph of a piecewise function, and we have to write out the function. So it starts with f of x equals, and then we're going to look at the parts. And you always want the function that is farthest left. So this one, it will go up top. So let's see, y-intercept 0, slope down 1 over 1. So that's just negative x. And then that is for the domain from negative 3 to 2. And it's not including the 3, but it is including that 2. Now for the other function, if I were to extend this following the same slope of that up 2 over 1, I'll have a y-intercept of negative 4, slope 2, so that's 2x minus 4, but that is only for the domain from 2 to 4. And that is not including 2, but it is including 4. So there's your full video on piecewise functions, evaluating, graphing, and writing them. Good luck with your lesson.